Hello everyone. In this lecture, I will be discussing sequential circuits. Digital circuit is a logical circuit that performs logical operations. Basically, digital circuits are classified into two types: combinational circuits, sequential circuits. Combinational circuit is a logical circuit in which the output depends on the combination of the inputs. That is, the present output depends only on the present input. A combinational circuit can have any number of inputs and any number of outputs. Next, coming to the sequential circuits. In the sequential circuit, the output is a function of the present input and a sequence of past output. That is, the present output depends not only on the present input but also on the past outputs. Let us take a very simple example for the sequential circuit. Consider an automated system where when a person enters a room, the light turns on automatically, and whenever the person comes out of the room, the light turns off automatically. There will be many people in the room. Unless and until all the people come out of the room, the light should not be switched off. So for this, the system should remember how many persons are there in the room. This is the basic idea behind the design of sequential circuit. For a system to remember the previous values, it needs memory. So, a sequential circuit is a combinational circuit with memory element. Let's compare combinational circuit with sequential circuit. As I said earlier, in the combinational circuit, the present output depends only on the present input. That is, memory is not required. Whereas in case of sequential circuit, the present output depends on the present input as well as past output. Hence, to store the previous output values, memory is required. Combinational circuits are faster since they do not involve any feedback, whereas sequential circuits are slower. And the combinational circuits are easy to design. The sequential circuits are harder to design. The examples of the combinational circuit, it includes half adder, full adder, encoder, multiplexer. And for the sequential circuit, the examples include counters, registers. Next, how to store a bit. The two NOT gates connected in cascade with the feedback, it forms a basic storage element. Let us assume the input of the logic gate is 0. Then the output of the first gate, it is logic 1. So the output of the second gate is logic 0. The same 0 is fed back to the input. The output remains 0 as long as the circuit remains unchanged. The same exists for the input 1. The important point to be noted is that how to set the values to 0 or 1. For this purpose, we need additional circuit. And depending upon the circuit used, there are different types of latches and flip-flops. The latches and flip-flops, they are the basic memory elements. Latch. The latch is a memory element which is capable of storing 1-bit information, either logic 0 or logic 1. That is, it is having two stable states. Hence, the latch, it is a bistable element. The 1-bit information can be locked or latched, and hence it is referred as latch. The latch consists of cross-coupled inverters connected back to back. And the latch, it is a level sensitive element. It means the circuit operation depends on the voltage level, that is high level or low level. So this is the basic symbol for the latch. So it consists of either two inputs or one input depending upon the type of latch, and two outputs. Q is the primary output, Q bar is the complementary output. Next, clock. clock, it is a control signal. The clock, it is a periodic rectangular pulse train that synchronizes the operation of the circuit. The circuit can be active either at the positive edge or at the negative edge. The other memory element is the flip-flop. The flip-flop is the extension of the latch. The combination of the latch and the clock, it contributes flip-flop. In the flip-flop, the output will change whenever the clock is active. That is, it changes its state in synchronism with the clock. And again, the flip-flop, it is going to store one bit of information, either logic 0 or logic 1. And the flip-flop, it is edge triggered memory element. That is, the output changes only during the positive edge or during the negative edge. And depending upon the number of inputs and how the output changes its state, there are different types of flip-flop. SR flip-flop, that is set reset flip-flop. D flip-flop, that is delay flip-flop or data flip-flop. JK flip-flop, that is Jack Kilby flip-flop. So this Jack Kilby is the name of the inventor of this flip-flop. And T flip-flop, it is toggle flip-flop. So these are the basic symbols for the flip-flop. And CP, it represents clock pulse. And JK, it represents the input. Q bar represents the output. Q, it is primary output. Q bar, it is complementary output. So next, coming to the triggering methods. In sequential circuit, the output changes depending upon the triggering. There are two types of triggering. The one, it is level triggered. The other one, it is edge triggered. As I said earlier, the latches are level triggered and flip-flops are edge triggered. In the level triggering, the output is allowed to change during either the higher level or lower level. So depending upon whether it is high or low, there are two types of triggering. One, it is positive level triggering. The other one, it is negative level triggering. In the positive level triggering, during the entire positive level, the latch will be enabled. Any change in the input will be reflected in the output. And similarly, in the negative level triggering, the latch will be enabled during the entire negative level and any changes in the input will be reflected in the output during the entire level of the enable input. So next, coming to the edge triggering. In this case, the output is allowed to change only at the positive edge or negative edge of the clock. And depending upon positive or negative, there are two types. One, it is positive edge triggering. Another one, negative edge triggering. So in positive edge triggering, the output will change only at the positive edge. And similarly, in the negative edge triggering, the output will change only at the negative edge. In the remaining cases, the output will remain unchanged. So finally, coming to the types of the sequential circuits, there are two types: synchronous sequential circuit and asynchronous sequential circuit. In the synchronous sequential circuit, the system behavior is mainly dependent on the clock signal. Here, the storage element is flip-flop. Since the circuit operation is depending on the clock, the circuit it is slower. In case of asynchronous sequential circuit, the system behavior depends on the input signal at any instant of time and the order in which the input it is changed. Here the storage element is time delay element. The asynchronous sequential circuit need not wait for the clock, so the circuit it is faster. And here the storage element is time delay element, that is, the internal propagation delay of the logic gate is sufficient to produce the needed delay. Thank you. Happy learning.